So we have function f of x, 4x squared plus 6x minus 15 in my case, I think. As I just said, just knowing this thing in circle and thinking that's, do you know the quadratic formula? Well, that's the hard part. Okay, remembering this. And it seems that everybody here remembers it. That's good. But nobody remembers what it means. Well, most people don't remember what it means. Okay? And I really don't see any evidence that people instantly knew what this means. So, not getting on you or anything, just telling you, you want to know what it means. Because, of course, this is to prepare you for what you're going to see soon in your pre-calculus class. Okay? You want to know what this means. Now, just knowing this formula, that's good, but it just takes a little more to understand what it means. And the way I stated it is that ax squared plus bx plus bx plus c equals 0 if and only if x is one of these two values. Now that tells you something about the function. This by itself, if you don't know the rest of it, doesn't tell you anything. You certainly know how to plug in and evaluate, and everybody's doing that well. Okay, so also, Y-intercept happens when x equals 0. I mean, the y-axis, all the points on the y-axis have x coordinate 0. The y-intercept is the point on the x-axis corresponding to this function. Okay? So we have two important principles. You have to understand these principles before you can apply them. And it's not hard to understand them. You're on the verge of doing that, but you're not quite there. Okay? You weren't quite able to apply them to this situation. Of course, if you look at the videos from last time, we talked about them in detail. Okay? So you might want to review those, because I'm not going to repeat what I said before. I'm going to use it. Okay, so you have to know the quadratic formula, the whole blame thing. Okay? Know all of this, not just the circle part. And when you do a few of these problems, then you'll know how it's used. Okay? But when you start out, you got to know what the statement is. Okay. Then y-intercept happens when x equals 0. Okay. So also when we graph this, we're graphing y equals f of x. Well, that made it worse, didn't it? Okay. But there it is. So these things in blue are things that you just have to totally understand and do if you do a few of these problems by hand. Okay? Now, if you do these problems by using your graphing calculator and graphing these things using your graphing calculator, you're not learning much. And you're not learning what you're going to need to know when you take a test that doesn't allow the graphing calculator. Okay? That's certainly true in my sections. I think it's true in all sections. You've got to be able to do these using the principles. Graphing calculators, if you're using a graphing calculator, you're using it as a crutch, and you're never going to learn to walk. Okay? Well, I think you will because you're smart. But, you want to learn to walk now, not at the last second when you forget everything. Okay? Because you're on a test under this pressure. Okay, so anyhow, these are three principles. This, and this. You simply have to know these are true. And this and this, of course, are true no matter what your function is. Now this applies just to quadratic functions and quadratic equations. Okay, so what do? using the quadratic formula, we find and I'd like you to write out every detail of the reasoning. Because if you do that, you learn the reasoning and you get used to the reasoning, so you don't have to rely on black magic. Okay? You don't have to really rely on, oh, when I see this, I'm supposed to do that, and there's a formula for this, and so forth. And you forget half of that under the pressure of a test. And also, you don't learn it well enough to apply it beyond the test because you forget it right after the test. Which is really inconvenient, and of course it has a final exam. Okay? You can't be forgetting stuff. So by reinforcing this, writing out what it means in every step, you learn how to do it. You learn what it means so that you can apply it to other situations. Okay, so from this, we can conclude that f of x equals this, which equals 0, if and only if x equals negative 4 plus or minus the square root of 6 squared minus 4 times 4 times negative 15, all divided by 2 times 4. We do the arithmetic, we get negative 4 plus or minus. That's going to be 36, and that's going to be 240, so that's 276. Okay, we can do a little arithmetic on 276. We can divide 276 by 4, 4 being a perfect square. So we know that 276 equals 4 multiplied by 69. So the square root of 276 is the square root of 4 times the square root of 69, which is 2 times the square root of 69. Now 69 is 3 times 23, 3 is prime, 23 is prime, so that can't be factored. But we can factor out the 4 from the 276, so factoring out a square root of 4 from the square root of 276, we get this. Of course, now we find we still need to use a calculator. You don't know what the square root of 69 is. I'm not sure, but I think it's about 6.3. Okay, maybe a little less. So I'm just going to use my approximation. It's between 6.2 and 6.3. I'll say that's about 12 and a half. Negative 4 plus 12 and a half is about 8 and a half. So that's about, I'll just say 1.1, or negative 16.5 over 8 is going to be negative 2.1. Okay, you can take a calculator and improve my numbers. Well, that's what we get from the quadratic formula. F of x is 0 if x is one of these numbers. Okay? So my short version of my conclusion is this. And that kind of works out. Okay. Now, the next thing is the y-intercept happens when x equals 0. Well, this tells you that it's really easy to plug 0 into a quadratic function. Because this and this are both going to be 0, you end up with this. So the y-intercept, you let x equal 0 to get this, so the y-intercept is 0, negative 15. X is 0, okay? If you don't write out words around it, you're going to do things that I see a lot. I think I saw at least one instance where somebody did it. They said, well, okay, so something like, okay, the y-intercept is 1.1, negative 15, okay? Doesn't make any sense because you let x equal 0 to get this. So if you're just kind of imitating what you've seen, you're not really thinking about what's really going on. That's okay. If the first few problems you do, you have to imitate, that's okay, but you want to get past imitation, understanding why it is. Because your knowledge is more secure, it's deeper, and everything else is going to go better. Okay, so anyhow, now, what do we know? Well, now I'm going to say y equals f of x equals 0. Because of course y equals f of x. And we're using the fact that y equals f of x. So if f of x is 0, that means the y value is 0. And if that occurs when x is 1.1, then you have the point 1.1, 0. These are approximately. They're on the graph. So now, I can sketch a graph with those 3 points. So my 3 points are going to be negative 2.10, so that's about here. That's a bad place to label it, let me improve that more. Have to change a bunch of stuff. So this is the point. Negative 2.10. And if that's negative 2, approximately, that's negative. Okay, so 1.1 ought to be probably about here. Of course, you can always draw a scale. And there's 1.12. Now the y-intercept occurs at negative 15. Now I'm not going to put the y-intercept too low because I know what's coming next. You want to leave yourself plenty of room on the graph. And I'm abusing the scale a little bit, but the graph would be really skinny if I used equal scales. So here's your y-intercept. It's 0, negative 15. And I just did what I said I was going to do. I'll put that point off higher because I know the vertex is going to be considerably lower. So I'm going to put negative 15 way up here, leave myself plenty of room to get to the vertex. Now the reason I'm going to do that is I know that I've got to draw a curve that is of the shape of the x squared curve. That ought to be very familiar. It's a basic function. You've got to keep those basic functions in mind throughout the course. Otherwise we miss stuff. There are things we don't understand because we glossed over the basic functions. So we've got to put a parabola, which might look something like this, through these 3 points. Now how are we going to do that? Well, got to go through this point and this point, got to come down to a low point and then come back up through this one, right? The low point isn't going to be here because that would make the parabola lopsided. It doesn't look like this. It's nice and symmetric about its axis of symmetry. Okay? So this is symmetric. And this is no way it's symmetric. So just because this is a Y-intercept doesn't mean it's the vertex. And the vertex, of course, is here. And if the vertex was here, it would be symmetric. Okay, and this is what it would look like if you tried to go through these points and make this your low point. You'd have to come down here gradually and have to turn around real quick to get back up. It would be lopsided. It's got to be symmetric. Now I'm just going to draw it, and I'm not going to think about where the vertex ought to be. And then we'll see if the vertex turns out to be where it should. Okay, so I'm going to come down here. Okay, so I think it's going to look something like this. Right? Not great. Now where's the vertex? Well, the vertex is where a horizontal line would be tangent to it, so it's right about here. So here's your axis of symmetry as I've drawn it. As I've drawn the parabola. I'm actually fairly good at drawing parabolas, but not great. But I kind of maybe lucked out on this one. That kind of looks to be about where it ought to be. Well, if negative 2 is here, negative 1 is going to be halfway between here and here. So here's x equals negative 1. What do you think the coordinate of the axis of symmetry is?
0.9, negative 0.9.
Yeah. Yeah, maybe go with negative 0.7 or 0.8. It's not quite that close, but 0.9 is an okay estimate. Okay, 0.9. So I'm going to use that. Of course, it's negative 0.9. Okay? Now, how do you read the axis of symmetry out of the quadratic formula? Did this last time, but I have to say, okay? Okay, these 3 principles and suffice to give you 3 points that you can fit the graph to. They don't tell you where the vertex is, but if you draw the parabola well, you'll be fairly close. So you kind of test how close. Well, Now, that's not the whole quadratic formula, but that's the part we want to look at to find the axis of symmetry. So another important principle is that here's your axis of symmetry. So we just kind of throw this away. So the axis of symmetry is that x equals negative b over 2a. This is not an extra formula to memorize. It comes right out of the quadratic formula, because if you have symmetry, the axis of symmetry has to be halfway between your zeros. And if you look at the homework, you understand what I mean by zeros. It's a point where the graph goes through the x-axis. In other words, a point where y equals 0. Those are your zeros. And you need to know that language because that's going to be on a test. Ask you to find the zeros. You have to know that's where y equals 0. Okay? So the value of the function is 0, and that's going to be points on the x-axis. Of course, it's possible that a parabola could be a little higher. You can vertically shift this, it's still a parabola. So high it doesn't go through the x-axis, right? Or an upside down parabola so low it doesn't go through the x-axis. In that case, you're going to get a negative under this thing. You can't do the square root of a negative, so that means there is no value of x. So we kind of want to know that too. But concentrating on what this tells us about the graph, in this case, x equals negative 6. Uh-oh, you know what I did? Throughout this thing, I was mixing up the 6 and the 4. A big bonehead error there. And having done that, well, that's not going to rescue me. Okay, so this is wrong. It's not going to check out. I can't just switch those because I squared the 6 to get those points. Well, I'm still going to go back to what I had, since I was kind of committed to it. Okay, you see where that messes me up, because I use the 4 here. That should be negative b. That should be negative 6. And this should be 4 squared. Okay, I'm going to have to correct it because we want to see how it works out. I substituted the wrong numbers here. kinda got kinda messy. Okay, I'm gonna do the correction, then we'll continue the video.